So once again, welcome. Yeah, I can see you have a few people who have joined us. So thank you so much for making time this afternoon to just listen in and learn something about KC, about GIS, about Earth observation. Yeah, it's good to see you. So today we have an interesting topic. Yeah, it's called GIS data types and analysis, where I don't want to give more details, but you'll be given more details. It's basically beyond the satellites that we launch to space. Yeah. How do we get to analyze the data? What kind of data does it give us? And how do we use the data? Yeah, so a bit of the Kenya Space Agency for those who are new or those who are here for the first time. So the Kenya Space Agency is basically parastatal that its mandate is to regulate, coordinate, and promote all the space-related activities in the country. So in the quest to promote space-related activities, that is why we hold such a webinar at such a time, just to give you some foundational information, rather knowledge about you can say space science, yeah, something like that. Yeah, so other than the webinar, we do outreach, we do a bit of literacy materials where we break down these, the jargons of science into a way that you understand in different levels. Yeah, so, and today, the webinar, yeah, we endeavor to have such an interesting conversation, yeah, such an interesting meeting where you get to learn something new. So if you have any question at any point, just you can raise your hand or you put your question in the chat. There will be someone to attend to you. So enjoy. Our speaker for today is someone called Esther Maina, who's going to take us GIS and GIS data types and analysis. Yeah, that's I can see a quick question there. We can organize webinars for weekdays. Yes, we can. We will consider that and see how it fits into the planner of maybe the students, the learners, and also the planner of KC. Yes, it's something you can consider. So thank you so much for that quick question, and over to you, Esther.
Good afternoon, everybody. Thank you for joining. I hope you can hear me. Somebody just confirm that I am audible enough. Okay. So as John has said, my name is Esther Maina. I work with Kenya Space Agency as a remote sensing officer. I have a background in geospatial, and today we are looking at what is geospatial, what kind of data I deal with, and what kind of data I analyze. So basically, a geospatial expert is one who analyzes data that is coming from the satellites to make meaningful insights from that data that can be used for decision support in various sectors. So I'm going to share my slides. So yeah, and just before we begin, as Joan has said, if you have any question, feel free to write it on our chat box so that we can be able to answer to you as we continue. And also, we'll have a question and answer segment towards the end of the webinar. So if you're not able to write it at the comment section, we'll give you an opportunity to ask once we are done with the webinar. So today we are talking about introduction to GIS data types. So maybe just even before, sorry for that. So before we continue, maybe someone can join in or type in the chat box and tell us if they have ever heard about GIS data types, or this is totally a new aspect to you. So I saw Jasmine in the meeting. Are you able to unmute and tell us if you have heard about GIS? Do you know about data, or what comes to your mind when you hear data types? Any other person who is able to unmute? Yes. Yes. Yes.
It's actually very new to me.
Okay. Sly, I saw your hand up. Thank you, Jasmine. If you're able to unmute, Sly.
Okay, so for me, I've heard about GIS data types. I've heard about vector and raster data.
Good. So we have two categories of there are people who have not heard about data types. There are people who have an idea of what data types is. So today, at least, we get to be on the same side as we learn together. So to start us off, so this is our outline for the study today. So we are going to talk about briefly what is GIS, what data types we have, what data models we have, and also look at the sources of these data types and how these data types or this GIS data is applied in different sectors. So
are you on leave?
Okay. So for GIS,
Next week we are officially off.
give me a minute.
But Hillary is not coming. Hillary. No. Oh, it was only Esther.
Yeah, on leave, so I had to.
Yes, sorry, I'm back. Sorry for that. So what is GIS? We are looking at GIS in three different forms. We are talking about just geographic information systems. GIS can be, the abbreviation can also stand for geospatial information systems and geospatial information science. So there are two aspects of it. It could be in terms of the systems, and it could be in terms of science. System to mean it is a tool or a methodology you use to get different insights, and science to mean that it's a field by itself, something you can study and produce results with. So the focus today is on data types. And to start us off, we are talking about geo being representing Earth and spatial representing location. So we are defining the location of an area using something we are calling the data, which can be represented in two aspects, for example, as coordinates, that is the X and Y. So the simplest way of thinking about it, when you want to locate a location or when you want to identify a location in a map, you are able to do it using spatial data, that is the X and the Y, which denotes the exact location of that place or of that point. So there are two types of geospatial data types. That is the spatial data that has the X and the Y, for example, the coordinates, and also the attribute data that now gives you the name. A good example is the Kenya Space Agency have our offices at Pittman House. So there are two ways we can represent Pittman House. Number one, in terms of the X and Y, that is the coordinate. So we can give the location of Pittman House in terms of the coordinates, that is the X and the Y. So that's basically the longitude and the latitude that places Pittman House in the map. And number two, we can represent the location of this place by mentioning the name. As I've said, it's Pittman House. So those are the two ways we are able to represent a location of an item or an area or of a place. So coming to data types and their characteristics, so we have two characteristics of data. And number one, as somebody had earlier mentioned, we have the vector and we have the raster. So on the vector, this is the kind of data that is represented using elements such as a point, a line, or a vector, or a polygon. So when we talk about point data, it could be an identifier of a location. Say, if I tell my friend that I am dropping them a pin, if we plan that we are meeting at a certain and certain hotel, say Serena Hotel, and somebody in our team does not know where Serena Hotel is, I will tell the person, I will drop you a pin. So that pin is in form of a point that is represented by coordinate, the X and Y, the longitude and the latitude. So that's a representation of a vector data type in point form. For the line representation, we have an example of a road. So you will draw a road by showing it in form of a line, or a river. You will depict it in form of a line. And then there is the polygon or a boundary. For example, in this map of Kenya here, it is one polygon that has different polygons inside of it. So the larger polygon is showing the boundary. So in most cases, the polygon representation shows boundaries. Like for this case, it shows the boundary of Kenya. And then we have the smaller demarcations or the smaller showings that represent the different counties we have in our country. So those are the three representations of vector data. Then moving on to the raster data, it is represented in cells and pixels. So when we will see this later in our activity today, but just to explain, each data or each image, so raster can be simplified by saying that it is a representation of data in form of images that when they are broken down, they are small boxes of data, small boxes of images that are joined together. So if, for example, you have ever done a puzzle where you're putting the different pieces of images together, so those small pieces, those small pieces that make up the bigger picture are what we are calling cells and pixels. So each cell, each pixel has an information that when joined together by other cells and the pixel, they create the bigger pixel. So for the raster representation, the image or whatever kind of information you're presenting has low precision. It means it has low accuracy. And for raster, it occupies a lot of space or a lot of volume. So most of the raster representation they are big in size. But for the vector representation, they are more accurate because, for example, if I send you a pin location for Serena Hotel, when you use that pin location, you will get exactly to Serena Hotel. And the other advantages of using vector representation is they occupy or they have low storage or volume when you're using the vector representation. So moving on to data models. So a model is just a mathematical structure or a digital structure representing whatever is on the earth. So for vector, its representation on earth is, or how you're able to put on earth the vector data types is a collection of points, lines, and polygons that I have previously explained. So for example, on this side, I have vector data that is mathematically represented using points, using lines, and also using polygons. So we have different points, and when you join the point, you're able to see, for example, a line, and the lines, when they are joined together, they create a polygon. So for the raster data, so the same data that is represented by points can also be represented by pixels on the raster data. For example, you can say this is point A, this is house 1, but the same house can be represented in form of a pixel or a cell in raster data format. For the vector, for the line feature, or for example, if you're talking about a road, the same road can be represented in raster format by creating a line or by joining together a number of cells and pixels as depicted in this photo here. In the same manner, when you have a polygon feature, the same polygon can be represented in raster data format by having similar pixels or similar cells joined together to create the polygon. So for vector, you draw simple things like the point, the line, and the polygon, but for raster, it is just a representation of cells and pixel that can either represent one dot to denote a point, or joint cells and pixels to show a line, or similar cells and pixels to denote a polygon. So there are several sources. Okay, there are numerous sources of geospatial data, or the GIS data that we are using, and I will just highlight a few of them. So we have the GPS, which can be handheld GPSs. We have LiDAR data. A good example is people who, so in a few years ago, one of the most common ways of taking data was using aeroplanes. So when aeroplanes are up there, they were being used to map and show data of the surfaces of the earth. So that is what we call LiDAR. And then we have special instruments that are used by people in the geospatial sector, such as the total stations or the RTK, that also take geospatial data. And then you can go mapping in the field, that gives you the field data. And then the common usage that is maybe commonly known by people is the satellite data. So once the satellite is launched up in the space, it takes images of the Earth, which is what we are calling the satellites and the imagery, the aerial imageries. So that's another source of geospatial data. So moving on to the applications. So geospatial data is very key and is very useful in our day-to-day activities. And some of the applications that we have for using geospatial data are, for example, mapping topology. So topology generally shows what's on the surface of the Earth, so giving different elevations. So for example, in the image that we have here, we can see that this area has a few hills, and then we can see there is a river that is flowing here, and then we have some water being collected here. So the topology shows the different elevations on the surface of the earth. So some places are flat, like the parts that can be seen here. that seems a bit white. And then there are some surfaces that are hilly that can be shown here. And then we have a river flowing. So basically it shows the high grounds and the low grounds. So the different colors that you're seeing on this topology image here denotes the different elevations. So we have the green one here, and then it goes up to the yellow, and then it goes up. So the different elevation is represented using different colors. Another example of an application of geospatial data is showing different temperatures of the surface of the earth. For example, this is a portion of the world map that shows different temperatures on the surface of the earth. So there are places that have are a bit cooler, there are places that are a bit hot. So that is what is being shown by this image here on the temperatures. So again, different temperatures are represented using different colors. So for example, if you're able to see, we have a scale here that shows the temperature ranges of the image here. So others are in 24 degrees, others are in 20, 23, as it changes depending on the temperature on the surface of the earth. Another example of an application of geospatial data is in land use and land cover mapping. So basically, if we want to know which part of Kenya is under agriculture, or which part of Kenya has buildings on it, which part of Kenya has conservations, and to show the different rivers we have in Kenya, what we do is land cover land use mapping. So it shows us this area is under agriculture, this area has buildings, this area has forest, this area has conservation, and so forth and so forth. So that is basically how we classify land using geospatial data. So so in simple terms, showing what is where on the surface of the earth. So if it is agriculture, it is classified as agriculture. If it is buildings, they are classified in their own. If it is mining activities, if it is forestry, if it is trees, and that is how we are able to know what is happening in a different piece of land. So for example, the government has given us, has taken up the agenda of planting more trees. So for us to know if that is happening, we do environmental mapping. Environmental mapping shows us what is in our environment. So we can do a classification that tells us there is trees in this area, there is a forest in this area, there is some mining activities happening in this area. So for example, using this image that we have under environmental mapping, we can see there are trees here, there are trees here, then there is a water body over here, and then some trees are seen as being cut in some parts here. So for the government to be able to monitor if we are truly planting trees or if we are increasing in our tree cover, they use the environmental mapping to show which area has more trees, which area is showing that trees have been planted over a few or over a number of years, comparing what was there last year or in 2010, in 2020, in 2015 to what we have in 2024. So we are able to know the increase or the decrease. So in this case, the afforestation or the deforestation by using geospatial data and comparing to what was there a few years ago or even a few months ago. Another example of how geospatial data is used, in this case, looking at the vector data, a key example is on property boundary. So for you to own a piece of land, you need to know where that piece of land is located on Earth. Or if you place a global map or a Kenyan map, you would be able to pinpoint that my piece of land is in this area. So that is what we are calling property boundary or property mapping. So an example of the image we have here, we can see there are different shapes. There are different shapes of the boundaries of the various properties on this image. And this image helps us in management of, say, the real estate, management of land distributions, and also land registration. So property mapping helps us in managing things to do like the real estate, land registration, and also helps us in acquiring land information systems. Another example of an application of vector data is in mapping of, say, major roads, because major roads are represented using lines. So you're able to see these are the different major roads we have in Kenya. Another example would be in showing or representing the different rivers we have in Kenya, because they are also represented using the line representation. So as we move towards the end, just to highlight a few of the careers that we have in the geospatial industry, or a few careers that you can be able to pursue if you're interested in GIS, if you're interested in geospatial. Or one of them is remote sensing. So a remote sensing officer is someone who looks at the images that are acquired in, for example, using drones or using satellite images, or the data that has been acquired in the field, and analyzes that data to be able to have meaningful insights that can help in decision making. A geospatial officer also looks at analyzing data in forms of vector or raster, and also be able to give insights that can help, say, the government or an institution or an individual make decision based on that data. Another career opportunity is in land survey. So land survey is somebody who manages the land resources in terms of telling you your land is maybe 2 hectares in size, and a land surveyor also is able to do subdivisions of land or verify that land is genuine. So a good example is if you want to buy land and you would want to know whether the one who is selling that land to you is the genuine owner, you get into contact with a land surveyor who is able to verify whether the one who is selling to you is the actual owner, because you don't want to buy land and then have issues later in when you're told that that land was probably a road reserve, or it was grabbed from somebody. So you use a land surveyor to verify that that land, the owner or the one who's selling the land to you is the actual owner, and also to verify that the area or the amount of the area that the person is telling you the land, if the person is telling you that the land is 2 acres, you use the land surveyor to verify that it's actually 2 acres of land that are being purchased. Another example of a career is in engineering survey. So these are surveyors who specialize in engineering field or in engineering sector. Say, for example, things to do with construction of roads, constructions of buildings, to ascertain that that land can be able to support the building that you want to put up. So when you want to build a house, you have to consult an engineering surveyor to tell you you want to put up a 10-story building, but based on the properties of this land, based on the elevation, based on the analysis that we have done on the soil, this land cannot be able to support 10 stories. It can be able to support only 4. And that is very important, because we don't want you to build your house and then 1-2 months down the line, the house comes down because the ground was not strong enough to support it. So yeah, that is why engineering surveyors are very important. And they also there are few of them who also specialize in mining as an engineering surveyor. So to determine if your land has minerals and which is the best way to mine those minerals. Another example of a career opportunity is in environmentalists. So these are people who are passionate about our environment, and they would want, and they're involved in things to do with mapping the environment, restoring the ecosystem, or ensuring that the environment is in the best way. So for today, we are going to engage in an activity, and so we will do it in 2 ways. Yes, if time allows us. So we are going to watch a video of how the different data types can be mapped in a simple way that each one of us is able to. And for this activity, we are using Google Earth engine, which is Google Earth, which is an open software or an open application. So you can be able to access the Google Earth in 2 ways. You're able to type in your browser. Say if you're using Google, you can just open Google and search Google Earth, or in the different browser that you use, and you're able to join us. So I'm going to play the video of the activity, and then we'll come back and do a simple demo of the same just before we finish. So I would like somebody to confirm that you're able to hear the voice when I pressed play, or you're not able to hear. It's not playing. Okay, I'm told that you're not able to hear the voice of the video, so we'll do a live demo. Allow me to reshare my screen. Okay, so this is the Google Earth Pro, or just you can search just Google Earth. So when you open, this is okay. So just a minute, I can just do it on the browser so that we can Okay, so this is a browser. Just type Google Earth. So this is what you will, okay. So when you search, you will have these options. You click on the first one. It will lead you to this page here. You click on the launch app. Give it a few minutes to load. Yes. So this is the first window that appears when you click on the Google Earth. So you can see this is now the interface or how it appears. We have different icons, or we have different things that we can do here. So we are going to use this add place specifically for point data. And then we have this add path or polygon, which we are going to use for lines and polygons. So let's do a simple, so you can zoom using your mouse or touchpad, depending on what kind of an device that you're using. So in this case, I've just zoomed to where Kenya is, or alternatively, you can search using this search icon here. So let's search for Nairobi, or you just type the name there and you press enter. So in most cases, it will give you a number of recommendations that are similar to the name that you have searched. Just a minute as it loads. It's taking. Okay, it's taking quite some time to load, but basically that's how you zoom into your location, by just typing it there. So in this case, I've let me look for a place. We have a town, or some sort of buildings. Yes. So we will use this for our example. So we have the Consolata Primary School here. So this is a representation of a point data. See, it is represented by a point. And how, if you wanted to add it, or if you wanted to add an item or add a point representation, you come to this icon here that is titled Add Place Map. Just click on it, and then you put it to your area of preference. For example, let me put it there. So remember, in our explanation, we said that data is represented in two forms. So in terms of the polygons, or in terms of the coordinates, that's the longitude and the latitude, or in form of an attribute. So for this point data that we have placed here, you can see it gives you the coordinates, the southings and the eastings of this location. The attribute can be added. See, when you put the point data, it will ask you whether you want to name that location, whether you want to name your point data. So for example, I can say this is a school. And you see it changes now. The name school is an attribute that relates to this point, or that relates to our point data. So the point data can be represented either using the X and Y, that is the coordinate, or the attribute, which is in this case a name. Let's do an example of line representation. So if you see, we have a road passing here, although not a main road, but a road nonetheless. So if you want to represent this one, we'll just draw. You can see as I click, it draws. Let's do up to there. So for you to end a drawing or end a representation, you just double click on it. So when I draw this line, it gives you different things. For example, it has told me that the line that I have drawn, or the road that I have drawn, is 341.11 meters. You can change that into kilometers, which is about 0.34. So if you want to save it, it will give you an option of inputting a name. And you can say this is a road represented in form of a line. So to do, so you see this area that we have zoomed into, there are people who are involved in agriculture. So that is where you're able to see these pieces of land as where some activities have been happening. So if you want to do a representation of, a representation of this polygon, you'll come here and do zoom as close as possible, and then draw our polygon for this farm. Then when we get to the end point, we double click on it, and it forms a polygon or a body. And it gives me different parameters. Say it says that the parameter of this area that I have drawn is 0.34 kilometers, and the area of this polygon is as shown there. So that's how you're able to represent vector data formats, either in a form of points, such as a school, or in form of a line, such as the roads, the rivers, and then in form of a polygon to show any area that you would want to. So in this case, we have drawn a polygon in this piece of farm. Yes, and that's it for the demo. But for the Google Earth, there are different things you can explore. So for example, we have this icon on layers. It shows you different representations for the area. You can either add using this icon here. There is an icon for tools here. If you just wanted to measure without drawing, you come here and then measure. So a good example is if you want to know how far is the school, the Consolata Primary School, from this homestead here, or how far does a child from this home has to walk to get to Consolata. You just come here and measure. So you're drawing a line, but now specifically to measure the distance of that homestead to the school. So the child will probably come to the school all this way, and then use this road here to get to the school. And it seems like this is the gate here, and then get to the school. So up to that point, it is 0.7. So that is how you use the measure tool that is on the Google Earth Pro, or just Google Earth. So you're able to know a child from this home walks 0.7 kilometers to get to the school. So in a broader perspective, this kind of analysis can be used for things, for example, we call the network analysis or route optimization, so that you're able to know, is there any other route that this child can use that will be shorter, or that will make the child reach school faster. So in day-to-day lives, that application is what is used, for example, for people who are into Uber business or into delivery business, to know which route is faster for them to deliver your meal when you order via Glovo, or when you order an Uber to go from one location to another. So they use the route optimization. So the measuring of distances and determining whether there is an alternative route that one can use to get to that destination faster and easier. So that is what we are calling the route optimization. So yeah, so that's the representation of the different data types. So that's it for my side today. But if somebody has a question, I'm available to answer. Or a question or a clarification on something that we have tackled today, and you would want to know further, or yes. Let me stop sharing so that I can be able to see if somebody raises up their hand. Yeah, I can see we had some activities on the chat box, and I see there are answers that have been given. So yes, thank you for engaging us today. So if there is no other question other than what has been addressed in the chat box, I would like to give it over to Joanne. And thank you for being here with us today. And hopefully we'll see you in the next class.
Yeah, thank you, Esther, for such a formative session. I hope you have learned something new, I hope. Yeah, and something useful that you're going to apply in your daily activities, daily life, and even as you go to school, maybe. Yeah, if there's no any other question, I think we will take our mayor's question as a recommendation to the agency. And yeah, there's no other question. Yes, so thank you so much for making time to be here. We will see you next time. We'll send details of the next webinar to your email, and also keep checking our social media pages. That's where we also put the poster. And if you have any clarification, any questions, or maybe you want to listen again to what we discussed here, you can subscribe to our YouTube channel, that's Space Club, where you can, during your own time, you can go word by word and try to figure out what Esther was trying to say. Yeah. Otherwise, thank you so much. See you again next month. Bye.